Finally, we almost finished chapter 3. And chapter 2 and 3, we are learning numeric measures. So this last part of from chapter 3, we're actually going to exploring the numeric measure that you can use to measure relationships. So for instance, like before we learn cross tabulation, scatter diagram, so there are visually show you the relationship. They might not be that accurate because people still prefer to look at number to understand what relationship you are seeing. Therefore, in this part, since in chapter 3 we're literally learning the numeric measures, we're gonna learn a specific numeric statistic that you can use to measure the relationship. So when we are learning this part, I want you to pay attention on how to interpret the statistics. Always, when people see a number, they just see a number. Since you are taking this class, you'll go either help yourself make a better business decision, or you become an analyst for a business owner to help them make a better business decision. Ultimate goal is you have to base on this data to understand the relationship. Therefore, please pay attention on how you should interpreting those statistics. So let's look at our slides together. And so measure two variables. So we have two statistics going to learn in this part. Both of them can be used to measure the relationship. So the first one is called covariance. The second one is called the correlation coefficient. What I want to point out is in the real world, usually we use correlation coefficient. We rarely use covariance. As we are learning that, especially how we interpret the result, and you will understand why correlation coefficient is more popular than the covariance. However, you have to know that both statistics can be used to measure the relationship. So first, we're going to look at the covariance. I will show you the formulas, and please don't spend your time to memorize the formulas. So this is the formula we use to calculate covariance. What I want to emphasize here is, first of all, is the notation. So notation is the only one you need to remember. So we're using S to representing the sample. We're using the Greek letter sigma to representing the population. So we are using the subscript XY to representing, this is looking at the relationship between X and Y variable, okay? And so look at these two formula. Besides the difference of notation, the big difference is on the denominator. The sample is n minus 1, the population is n. So therefore, when we later look at the Excel, we actually have separate formula. One is for sample, one is for population. Okay, one sample, one population. So the formula, what I want you to learn is notation and the difference between sample and population. And so now we're going to move on to what we need to focus on. That is how you interpret your result. So for covariance, it can be any positive value and any negative value. So basically, the covariance range is from negative infinite to positive infinite. So after you use Excel to calculate covariance, you will get a number. When you get a number, what you need to look at is the sign, whether they are positive or whether they are negative. So if it's a positive, that will be positive relationship. Remember, it's like your supply curve, right? So both variable will move towards the same direction. That's how you interpret a positive relationship, like that, right? That's the trend line, y and x. Remember, we try to connect all chapter together. So if you got a negative value, then that will be negative relationship. Then the x, y will have this kind of negative relationship. Basically, when one variable go up, another variable will go down. One variable go down, another variable will go up. So they always move on the opposite direction, such as your demand curve, right? Remember, based on the covariance, we only can identify whether they're positive related or negative related. So this is the first statistics. So now we look at the second statistic. This is called a covariance. So covariance, so how we calculate covariance. So this is the formula we use to calculate covariance. So besides the differences, first of all, I want you to remember the notation. R, X, Y, that is covariance, sample correlation coefficient. And this is the Greek letter called rho. So rho xy, that is the population correlation coefficient. So look at the right-hand side of each equation. Besides the differences of notation, there were no other differences. And actually, when you watch the next video, we look at it on Excel. So we only have one formula you need to remember, that formula can be used for both sample and population. So the range for the coefficient is not negative infinite and positive infinite. So the range for correlation coefficient is between -1 to +1. So having this limit is good. Why? Because having this limit allow me not only to identify the direction of the relationship, positive and negative, but also I can measure the strength of the relationship. So how so? So after you use Excel to calculate this correlation coefficient, how you should interpret this result. So if the value is near -1, that indicate a strong negative relationship. If the value is close to 1, that will indicate a strong positive linear relationship. If the value is close to 0, that will be considered as a weak relationship. So to help you to fully remember understand how you remember how to interpret this statistic, and I will use this scale, and I will identify totally 5 values on this scale. First of all, -1 and +1. So this horizontal is the value for correlation coefficient, and the middle point here will be 0, right? The reason it's not negative infinite or positive infinite because the correlation coefficient has to be between -1 and +1. And then another 2 dot I need to identify is -0.5 and then +0.5, okay? So every time you got a value for the correlation coefficient, what you need to look at is the sign, okay? So that's the first step. See whether they are negative or positive. So if it's a positive, so that will be positive relationship, right? Positive relationship. And if it's a negative, will be negative relationship. So that's the first thing you need to identify, okay? Positive or negative relationship. After you look at that, and you look at if they are between -5 or +5. So if that's the case, between -0.5 to +0.5, that will be considered as weak. Weak. So if it's larger than 0.5 or smaller than -0.5, that will be considered as strong. Strong, okay? So this is strong as well. Sorry for my writing, using my mouth. It's hard. So now, after you know how to interpret the covariance and correlation coefficient, I want to ask you why correlation coefficient is more popular used, is being more popular used than the covariance. Of course, the answer is straightforward. If you're using the covariance, let me go back. If you are using the covariance, you only can tell the direction of the relationship, right? Either positive or negative. However, if you're using the correlation coefficient here, you not only can tell positive, negative, but also you can tell the strength. So this statistic gives people more information on the relationship than the covariance. Therefore, people are using the correlation coefficient more often than the covariance. Okay, so that's why we're using correlation coefficient. So before we end in this video and let you move on to the computer skill, and I want to mention one more thing, that is what I mentioned in these slides. Correlation is a measure of linear association, not necessary causation. And some people are doing the study. So like I said, increasing the variety of the product have a positive relationship with the revenue, the grocery store's revenue. You cannot see increasing the variety of the product cause the store has generate more revenue, because there are so many things can happen during the time they are increasing the variety of product. So for instance, during that period of time, the stock market is doing pretty well. So for each consumer, their dispensable income increased, therefore they want to spend more money. Maybe that's the reason. So you cannot prove if the increase in the variety of the product causing them to increase in the revenue, but you can find they have this kind of positive association. So to prove cause is very, very difficult. You won't be able to use a simple linear, this kind of correlation coefficient to prove it. You actually have to carry on some kind of experiment to control so many factors before you can conclude the x cause y or y cause x. And also, just because two variables are highly correlated, it does not mean that one variable is cause of the other. So this is very, very important because there are so many news agents when they're reporting the academia research, they are keep using cause. That's wrong. Usually the academia, especially like economic paper or business paper, only can prove the association. It's really, really hard to prove one variable causing another one. And so this is the two statistics you can use to measure the relationship between the two